Good day, viewers. In this video tutorial, I'm going to teach you in less than 5 minutes tangent to the curve and normal to curve. I'm going to teach you equation of tangent to a curve and equation of normal to the curve. Look at it. Find the tangents and the normal to the curve. X raised to the power 2y plus xy squared minus x raised to the power 3 plus 16 equals to 0 at the point 1 and 3. At the point x1 and y3. And as a solution. But remember, if you are new to this channel, endeavor to subscribe to enable me grow my channel. Your subscription is very necessary to me. Are you get what I'm saying now? Subscribe, like, share to your friends, comment. Your comments enable me to know the area I'm doing well and the area I'm not doing well. Thank you. Let's look at what solution. Tangent to a curve or circle. Then we say the equation of tangent line at a point P. The equation of tangent line at a point P, look at the point P, x1, y1, is given as, look at the tangent line. A line is drawn tangent to a circle. And you know, for you to draw a line in a Cartesian graph, you must have 2 points. For you to draw a line, you must have a 2 points. You cannot just draw a line without having a 2 points. For me to have a line, I must have a 2 point Q, X, and point Q. Point P, Q, X, 1, and Y1. So for me to have a line, I must have a 2 point plotted. So look at it. This line passed through the point tangent here at this point P. Then look at where the line is going. That means I have a line, points, 2 points. Then this line have a slope. For me to draw 2 points in a Cartesian graph, I must have a slope. Then what is slope? Slope. And I have y minus y1 all over x minus x1. Y minus y1 all over x minus x1. That's the slope from our origin. Equals to m1. m1 represents the slope. Equals to m1. m1 represents the slope of the tangent line. The slope of the tangent line. That's my m1 now. Then looking at here, I have my x minus y minus y1 all over x minus x1 equals to m1, which is the slope of the tangent line. Then now cross multiplication, I have my y minus y1 equals to m1 into x minus x1. This is the equation of tangents. Remember that this y1 is the point at the point where the line meets the curve or circle. That's the point. Then remember that x1 is still the point where the line meets the circle or curve. Then m1 becomes the slope of the equation, the slope of the line passing through that is tangential to the curve. Then we have already settled it. That's the equation of tangent. This kind of equation of tangent. Then which we are going to use to solve this equation. We are going to use to get the equation of tangent. They find tangent and normal to the curve. We are going to get the tangent. Then coming to this, I come to normal to a curve or circle. Normal to a curve or circle. Look at the tangent line and look at the normal. When you draw a line like this, a perpendicular line becomes a normal line to this line. So a normal to a curve is a line that draws from the center of that point of the circle or curve to the line that is tangential to it. So you now see this is line tangential. Look at the line of normal. That's the normal line. Look at the tangential line. Look at normal line. These two lines are perpendicular to each other. That's why you see 90. These two lines are perpendicular. Without them being perpendicular, that means this line is not a normal. Are you listening? I said, if this line and this line are not perpendicular to each other, it means that this line I call normal line is not a normal line. For this line to be a normal line is now perpendicular to what? Tangent. That's the condition. Condition for what? A normal line. It must be perpendicular to what? A tangent drawn to that the same point where he makes what? The circle or curve. Then looking at it now, since these two lines, this line has its own slope. This line has its own slope, and its own slope should be what? 2. That's the normal line. Equation of what? Normal has its own slope. Look at this. Its slope is what? M2. Then this line has its own slope, which is what? M1, which is called tangential line, and this is what? Normal line. So these two slopes multiplying themselves, the answer is -1. That's the condition for what? Perpendicular line. Two perpendicular lines. The slope of two perpendicular lines. The product of the slope of two perpendicular lines give me -1. The slope of two perpendicular lines that meet to any point give me what? The product of the two slopes give me what? Answer to be -1. Then since this time this give me -1, this is the slope of what? Normal, and this is slope of tangent. This is the slope of normal, and this is the slope of what? Tangents. Are you get what I'm saying now? Then now, the slope of normal and slope of tangent give me -1. Therefore, making the slope of normal subject of formula, I have it to be what? -1 over what? M1. And M1 is the slope of tangent. So inverse of negative inverse of slope of tangent give me slope of normal. Negative inverse of what? Negative inverse of slope of what? Tangent give me slope of what? Normal line. Since I have gotten the slope of normal line, I can form the normal equation. Equation of normal. Then let us look at the equation of normal. Equation of normal become y minus what? Y1 all over what? Yx minus x1, and it is equals to what? M2. Are you get what I'm saying? That's the equation of normal. But I know that M2 is equals to what? Negative inverse of M1. And what is the M1? The slope of what? Tangential line. Why this man is a slope of what? Normal. Then I cannot say that this y minus y1 over x minus x1 is equals to -1 over what? M1. I can remove this and put this over there. Then I have this to be what? Y minus y1 is equals to cross multiplication. I cannot say this time this will give me -1 all over M1 into x minus what? X1. And this become equation of what? Normal. This is equation of normal. This is equation of tangents. You see that equation of normal and equation of tangent are the same. But the difference here is what? Equation of what? Normal is negative inverse of what? Is applying negative inverse of slope of what? Tangent. Why this man is a what? Slope of tangent. If I get slope of tangent, negative inverse of it will give me what? Slope of normal, and I get the same thing. Look at this. The equation of what? Tangent, equation of normal. Then let us apply it in our question. Let us what? Solve our question right now. Let's solve the equation now. Since we have already know equation of tangent and equation of normal, let's solve the equation now. So what is my own main things I needed? The main things I needed here is to get the slope of tangent. I'll first of all get the slope of tangent before I can be able to get the word normal. I can't be able to get the slope of normal without getting the slope of tangent. Therefore, I first of all get the slope of what? Tangent. Looking at it, that's why they say find the tangent and normal. Assuming they say find normal, you will still find the equation of tangent. You still find the slope of tangent before you get the normal one. Get it me now? I think you get what I'm talking about. I said, even if the question said find the equation of normal, you will first get what? The slope of tangent, which you multiply with the normal to get you -1, then you make it subject of formula. Then looking at this, I want to get slope. And the function they gave me here is implicit function. Look at it. This is implicit function. In the other of my video, I taught you what I mean by implicit function. I taught you people implicit function in detail. So if you have not known of that, you have to go to that video to watch how to deal with what implicit function. Look at it. This is implicit function, and this also will help you to know, because we are going to differentiate this implicitly. So looking at this, this is implicit function. I'm going to what? Solve this using implicit function. How am I going to get the slope? You remember that slope is what? dy, change in y over change in x is equals to what? Slope. Are you get what I'm saying? And that's the slope of what? M1. I think you are following what I'm talking about. Change in y in respect to x is equals to slope, and is what? M1 slope, which is what? Slope of what? Tangent line. So, and that is all about it. For me to get slope now, I have to find change in this function in respect to x. Look at it. Change in this function in respect to x. Look at it here. That's my fake journey. Change in this function in respect to x will give me the slope. Then now differentiating this, I have to differentiate it part by part. This man, I'm going to differentiate x squared y in respect to x. Look at it here. Plus, look at my plus. Xy squared in respect to x. Look at it here. Minus, look at it here. Then I have what? X raised to power 3 in respect to x. Plus, look at it here. Differentiating 16 in respect to x. Then equal to, look at it here. Differentiate 0 in respect to x. I have started my journey. Then now, looking at here, I'm differentiating two things, x and y, which is different item, x and y. And this x and y I'm differentiating, what are they doing to themselves? They are multiplying themselves. That's implicit function. They are multiplying themselves. And since they are multiplying themselves, I'm going to apply what we call product rule here. What's the condition? What made me to know that I'm going to apply product rule here? Because these two things I'm differentiating, they are multiplying themselves, and they are different items, and they are multiplying themselves. This is x raised to power 2, this is y. Then what am I going to do? Applying the product rule. What is the product rule? Said y is equals to uv. That means y is a function of u and v. Therefore, if I'm differentiating uv in respect to what? X, I'm going to say, keeping my u, differentiate v in respect to x. I'm going to keep v, differentiate u in respect to what? X. Have you seen what I did? So what am I going to do? I'm going to keep what? The u, differentiate v in respect to x. So looking at this now, I'm going to keep x raised to power 2, differentiating y in respect to x. Plus, I'm going to keep y, differentiate x raised to power 2 in respect to x. Look at what I did. I'm going to keep x raised to power 2, differentiate y in respect to x. Plus, then keeping what the y I have already differentiated, keeping him untouched, differentiate what? X raised to power 2 in respect to what? X. That's finish about this. That's end about it. Look as I put in bracket. Plus, look at the plus. Then I'm coming to this now. The same thing applicable here. This man, I'm differentiating two things, and they are different items multiplying themselves. That's x and y is raised to power what? 2, and they are different items, and they are multiplying themselves. I'm going to apply what? Product rule as well. Therefore, I'm going to keep x, differentiate y raised to power 2 first. Look at it. Keep x, differentiate y raised to power 2 in respect to x. Then I'm going to keep y raised to power 2 untouched and differentiate what? Y, differentiate x in respect to x. I'm going to differentiate x in respect to x, and that gives me what I'm going to see here. I'll finish with this one. Then I come into this. This is only one function, depends on only the x. I have the x raised to power 3, look at my minus here, and I have x raised to power 3, plus, look at my 16 here, differentiating in respect to x, and is equals to 0. But let's see what I'm going to have here. Then coming here, this is the x raised to power 2. Remember, I'm differentiating y, and remember, whenever we are differentiating y is a king. Remember, in implicity, in explicit function, we have explicit function. As I explained before, explicit function, y is always a subject. Let's have what? X raised to power 3 for what? X plus what? 6. This is explicit function. But in implicit function, no one is a subject of formula. No one is a subject of formula in implicit function. In that case, I'm going to have xy plus what? Y squared plus what? 4x y equals to 2. This is implicit function. When I see something like this, is implicit function, indicates that no one is a subject of formula. Y is also entitled to be differentiated. Y is entitled to be differentiated. In that case, we call it what? Implicit what? Function. So when y is entitled to be differentiated, it means what? Is implicit function, and means that y is not a subject of formula. Get me right? Then now, looking at this, you see that what? Y is not a subject of formula here. That's why I know that is a what? Implicit function. Then looking at this now, when I differentiate y is a king. When we differentiate y, we must put an indication that y has been differentiated. And what's that indication? Y prime. Immediately I differentiate y, I'm going to give this indication that king y has been differentiated. Look at what I'm going to put here. I get what I'm saying now. If I don't put this, it means that I need to give a respect to y. So this is a respect. And what does this y prime mean? Y prime means the y dx. I think I told you before in the other video that y prime is the same thing as the y the what? Dx. That's the first derivative of what? X and y. Then looking at it here, I'm differentiating y here. Since I'm differentiating y, what I'm going to have here, the y dx, when I differentiate y in respect to x, the answer is 1. When I differentiate y in respect to x, the answer is 1. And that's this answer is 1. 1 times x raised to the power 2 will give me x raised to the power 2. I have to indicate that y has been destroyed. The king has been differentiated. And I have to put what? Y prime. That's why you see x raised to the power 2 y prime. You remember that when I differentiate y in respect to x, it will give me 1. You remember, I have done that, it give me 1. And 1 times x raised to the power 2 will give me x raised to the power 2. Then this man now, y prime, is indication that y has been differentiated here. Plus, look at my plus. I keep y out. This y here is untouchable now. I am now differentiating x raised to the power 2. Differentiating x raised to the power 2, we take these 2, multiply x minus 1 from the 2. When I use these 2 multiply x, I have 2x. Minus 1 from the power, I have x raised to the power 1. And x raised to the power 1 is x. Then what I have here was 2x times y will give me 2xy. 2x times y will give me 2xy. I close the bracket. Plus. This one, I'm not differentiating x here. I'm differentiating y. Remember, differentiating this y, I'm going to have 2y. And 2y times x will give me 2xy. That's why you see 2xy. Then what am I going to do? I'm going to give indication that y has been differentiated here. Look at here, y has been differentiated. I'm going to put what? Y prime to show that the king had been what? Differentiated. That king has been differentiated here. So when I have done that, I'm going to put plus. Look at the plus. Then now differentiating x in respect to x means the x dx. Look at it. The x dx. The answer is 1. Differentiating x in respect to x, the answer is 1. So when I differentiate this x in respect to x, the answer is 1. 1 times y squared will give me y squared. I put it in bracket. I come over here. Differentiating x raised to the power 3 will give me 3x raised to the power 2 plus differentiating 16. It does not contain x because this war is against what? Any people that contain x will survive the war. The war is done on x. That means I'm differentiating in respect to x. And this 16 does not contain x. Therefore, the answer becomes 0. The 16 becomes constant. Then the 0 dx will give me 0. Then coming over here, I'm going to what? Open the bracket now. I have 2xy prime, 2xy prime plus 2xy plus 2xy y prime plus y squared, this minus 3x squared, this 0 give me equals to 0. Then now, what's the next? I'm going to collect those ones that contain y prime in one side of the equation. I'm going to take those ones that doesn't contain y prime to the other side of the equation. Any side is of your choice. You can take it this side or this side. But one thing is sure, that I'm going to take those ones that contain y prime to one side of the equation and take those ones that doesn't contain y prime to the other side of the equation. Looking at it here, this one contains y prime, I keep it here. I take this one, it contains y prime plus, I put it here. And no one again contains y prime. I'm going to take those ones that doesn't contain y prime to the other side. I decided to take minus 3x over here, it becomes plus. Look at it, plus 3x squared. Then taking this man, look at this man, taking it over there, it become what? Minus, taking this man over there, it become minus 2xy. This one is crossing the bridge here, because minus 2xy. This one does not contain y prime. Taking it over there, become minus y squared. Are you get what I'm saying? This man contain, I retain them. Then I take this man minus 3x squared over there, it become plus. Then taking this man over there, it become minus, because he is one of the plus, become minus by crossing this equality sign. Then this man is plus, crossing the equality sign, become minus y squared. Then I'm going to make this man subject of formula. Now, collecting the like term, look at this one that contain y prime, y prime. Those one that doesn't contain y prime, I've taken it over there. Then now, this man contain y prime, this man contain y prime, which is this family have a y prime, this family have a y prime, so I have to bring y prime out. When I bring y prime out, I have to open brackets. Dividing this by y prime, it will cancel this. I have x squared. Dividing this by y prime, it will cancel himself, leaving me with 2xy. I have 2xy. I close the bracket. If I open this bracket now, I'll get this back. This times this will give me this. This time this will give me this back. And I have this. Then making this subject of formula, I have y prime equals to 3x squared minus 2xy minus y squared. Look at it here. All over, divide by this. X squared plus 2xy. What did I do? I divide through by what? X squared plus what? 2xy. I divide through this side and this side by this. When I divide this by this, divide it by this, I have this. So that's what I did here. Then when I have done that, I may remember what I told you, that y prime is something as dy dx, and which is my slope, which is what? M1. So looking at for y prime, I have my M1. My M1 represents what? Y prime, which is my slope, as I said earlier. Then now, I'm going to substitute the value. Remember, at point, what they said, at the point P1, 3. And what does it mean? At the point P1, 3 means this is x. The first value is x. Second value is what? Y. That means this x is 1 and y is 3. Are you get what I'm saying? This means x is 1, y is 3. So I'm going to put what in this place now? X to be 1. Wherever I see x, I put it 1. Look at it, 1 for this man become 1 squared. Then here 1, here what? 3, which is for my y. Then here 3 for my y. Then I'll come down here, put x1 and what? X1 again and 3 for y. Then doing the mathematical part of it, x1 squared will give me 1. 1 squared will give me 1. 1 times 3 will give me what? 3. Look at it here. And 2 times 1 will give me 2, times 3 will give me 6. Now I have minus 6 here. Then minus 3 squared will give me 9. Look at minus 9 here. Then 1 squared will give me 1 plus 2 times 1, 2 times 3 will give me 6. That's why I have 1 plus 6 here. I have 1 plus 6 here. And I have 3 minus 6 minus 9. Then I have minus 6 minus 9 will give me minus 15. I'm owing 66. I'm owing again 9. Total of what I'm owing is what? 15, which is minus 15. And I have 3 minus what? 15. This plus this will give me 7. 3 minus 15 will give me minus 12 over what? 7. Then I have that my M1 is what? My M1 is equals to minus 12 over what? 7. Then let me form the equation of tangent right now. I have gotten the slope of what? Tangent. Then now I can now form the equation of what? Tangent. Now, equation of tangent, which we have learned before, is what? Y minus y1 equals to m1 into x minus x1. At what point? At P1 and 3. You remember when we say P1, 3 means what? That this is what? X and this is what? Y. That means my y is 3 and my x is 1. Then now coming over here, I'm going to substitute my x, my y1, which will be what? 3, and my what? My x should be what? 1, which they give me here. The slope which we have gotten is minus 12 over 7. Then I'm going to do what? Arithmetic. This one now become arithmetic. Y minus 3 is something as y minus 3 over 1 equals to minus 12 into what? X minus 1 over 7. This thing is something as this. That's arithmetic. Because this times 1. You know that this minus 12 over 7 times x minus 1 all over 1. You now times the numerator times numerator, denominator times denominator, I have x. So this is something else. Then cross multiplication. Then you know that this one is multiplied this is multiplied this. I have this minus 3 times 7 equals to 1 times anything. 1 times all this is same thing as all this. So I have minus 12 into x minus this. Because 1 times all is the same thing as this. Then opening the bracket. 7 times y will give me 7y. 7 times 3 will give me 21. I have 7y minus 21. This one opening the bracket. Minus 12 times x will give me minus 12x plus minus 12 times minus 1 will give me plus 12. Minus 12 times minus 1 will give me plus 12. I'm going to arrange them in a what? Equation. Then I have what? 7y plus, taking this minus, look at over here, taking this minus 12x into this place, I have plus 12x. Then taking this man now here, this 12 into this place become minus what? 12. And everything over here is 0. Everything over here have gone over in the other side. And what is left here is 0. What is left here is 0. Then I have 7y next plus what? 12x minus what? 21 minus 11 will give me minus 33. Minus 33 equals to 0. And that's giving me equation of what? Tangent. Look at the equation of tangent. They asked me. That's my answer. Then now I come to what? Equation of normal. Equation of normal, which we know as what? Y minus y1 equals to what? Minus 1 all over m1 equals to what? X minus x1, which is the same thing as the equation of what? Tangent, but is only what? Inverse, negative inverse of the what? Slope of tangent. That differentiating from what? Equation of tangent. Looking at over here, I remember that m1 is the slope of tangent, which gave me what? Minus 12 over 7. Then inverse of it, what does it mean? What it means is what? Minus 1 divided by what? Minus 12 all over 7. That's what it means when I said minus 1 all over m1. What is my m1? My m1 is what? Minus 12 over 7. Remember, my m1 is what? Minus 12. Minus 1 is something as so minus 1 over 1 divided by what? Minus 12 over 7. Then this is something as minus 1 over 1 times 7 over minus 12. This minus 1 times 7 will give me minus 7. Minus 1 times minus 12 will give me minus 12. Minus cancel minus, I'm going to have 7 over what? 12. And that's what I write here, 7 over 12. And that's how I get 7 over 12. That means that inverse of this, minus inverse of minus 12 over 7. The answer is what? 7 over what? 12. This minus will cancel this minus, is inverted. That's giving me this. Now, let's substitute the value now into this equation. Let's substitute the value. I have y minus 3 equals to 7 over 12 into x minus 1, which we'll have over there. This man, y minus 3, is something as y minus 3 over 1 equals to this is something as 7 into x minus 1 all over 12. Cross multiplication. I have y minus 3 times 12 equals to 7 into x minus 1. Then opening the bracket, this time this will give me 12y. This time this will give me minus 36. Equals to 7 times this will give me 7. 7 times 1 will give me minus 7. 7 times minus 1 will give me minus 7. Then correcting the line. Thus, forming the equation, I have 12y. This man coming over here become minus 7x. Is crossing this bridge. This is minus 36. This man coming over here become plus. What will remain here is 0. Then I have the equation of normal, which is 12y minus 7x. Minus 6 plus this will give me 43. That will give me minus 40. That will give me minus 30. This will give me minus 36 plus 6 will give me 29. That's 29 equals to 0. Minus 36 plus 7 will give me what? Minus 29. Then minus 29, that means my equation of what number is minus what? 29. Then 12y minus 7x equals minus 29 equals to 0. That's my equation of what? Number. Equation of number is 12y minus 7x minus 29 equals to 0. That's my equation of number. And that's what we have for you today. We have seen how to calculate the equation of normal and equation of tangent. They are all similar, but what differentiates normal and tangent is different in their slope. So when you get the slope of tangent, you can be able to get the slope of normal. If you have not subscribed to my channel, please endeavor to subscribe to enable me grow my channel. Thank you for doing so. Thank you for sharing this video. Thank you for commenting. See you in the next